The lesson topic for this video is calculating the reference angle when given a point. So this is going to connect directly with what we had done in the previous lesson or two. We are going to start with a point somewhere on the coordinate plane, and our job is, instead of just finding theta prime, our reference angle, and then drawing the triangle and listing all of the 6 trig ratios, what we're going to be doing is actually trying to find the measure of that angle theta prime. So I think one example will suffice. So after I do this, hopefully you understand, and we'll do, of course, a bunch of practice in class. So the first thing we're going to do is we're going to draw or plot our point 5, -7. And we know that 5 is, doesn't really matter where we put it on this. So let's say that's 5 and this is 7. So our point at 5, 7 is right here. Okay, so our original angle is initial side on the x-axis, positive x-axis. Of course, our vertex is at the origin, and then we're going to come straight through there. So our original angle theta is this angle here, but we are trying to find theta prime, not theta, theta prime. Okay, so where is theta prime? Hopefully we're getting used to that. Theta prime is found by using the terminal side of our original angle and the closest portion of the x-axis, which is right here. So this is theta prime. All right, so we want to find the measure of that angle. What we've done in a previous lesson is we have connected, I should say, the point 5, -7 up to the x-axis in a perpendicular fashion. So we have a right angle, which forms a right triangle. Then we named all the sides, so we know that this is 5 because we went to the right 5, and we know this is -7 because we went down 7 to get there. And as we've shown in previous lessons again, we're going to go ahead and find the hypotenuse by using a squared plus b squared equals c squared, the Pythagorean theorem. We're looking for the hypotenuse, so we're going to go ahead and put 5 and -7 in for our a and our b. And we're going to try to find c squared. So 5 squared is 25, plus -7 squared is positive 49. Don't forget that it is positive. When we add those, we get 74. And we square root both sides. And we find out that c is positive or negative 8.602. And we know the length of the hypotenuse is going to be positive, so we can go ahead and put that in here, 8.602. Oops, there we go. That's a 0.6, there we go. Okay, so now we are trying to find theta prime, okay? If you look at this right triangle right here, and we know this side is 5 and this side is -7, and we know the hypotenuse, how can we find this angle? Well, hopefully you realize that finding that angle is as simple as using the trig that we had learned in our previous unit. And in this case, when you're trying to find an angle, as always, we're going to use inverse trig, right? So we're going to use an inverse trig ratio to find our angle, our missing angle, theta prime. So here's the thing. We currently know that our hypotenuse obviously is across from the right angle, so this is the hypotenuse. And across or opposite from theta prime, this angle, the opposite side is over here, so that's the opposite side. And this is therefore the adjacent side. We know all 3 side lengths. So if we know all 3 side lengths, we can actually use any of our trig ratios, sine, cosine, or tangent, in order to solve this problem for theta prime. Now, what would you choose? Think about that for a minute. If we're looking for this angle and we've got a decimal here and 2 whole numbers here, you might think about using tangent. Because if we use tangent, we use the opposite side and the adjacent side, right? And they're both whole numbers, which means we wouldn't have to worry about decimals. Doesn't matter, you don't have to, but that is what I'm going to choose to use. So tangent of theta prime is equal to Well, tangent is opposite over adjacent. The opposite side is -7, and the adjacent side is 5. So -7 over 5. All right, we know we can't take the tangent on our calculator of theta, a variable, so we are going to use inverse tangent. So we write tan inverse, and we, if you remember from, I'm sure you do, we switch these two things around. So tan inverse of -7 over 5 will be equal to the measure of theta prime. All right, so when we put this in our calculator, we're actually going to say, all right, the measure of theta prime equals, and we punch it into your calculator, and go ahead and try this if you don't mind. What you're going to end up getting is -54, pardon the bell, 0.462. All right, but here's the deal. Our measure of theta prime will actually always be a positive answer. So even though this right here says negative, we are going to go ahead and change that to positive, and it is 54.462 degrees. So we've now found this angle right here, the reference angle for an angle created by the point 5, -7.